steps forward, steps backward. So pointer, switch on.
Okay, good afternoon. Since I'm standing between you and the coffee, I will try to be as brief as possible. So, as you know, in many countries, radon barrier materials or standard waterproof materials are used as a basic measure against radon from the soil. So the problem is that nowadays we have no generally applicable or harmonized requirement for radon barriers. So we do not know how to find from the standard waterproofing membranes the membranes which have sufficient radon barrier properties. So there is no European or international standard that will set or prescribe some requirements for radon barrier materials. So the method of designing these barriers differs between countries. So generally, I found 6 approaches how to design these membranes, just in Europe only, and they are based either on radon diffusion coefficient or the thickness of the membrane or the radon diffusion length or the ratio between the radon diffusion length and the thickness or radon resistance. So now I will try to make some summary of these approaches. So the first one is the setting the maximum value of the radon diffusion coefficient. This approach is used, for example, in Ireland. The problem is that if I have different thicknesses and the same radon diffusion coefficient, I will have different radon resistances. So this approach, in fact, does not express the real barrier properties of the waterproofing product. The second approach is that we can set the minimum thickness of the membranes. This is applied, for example, in UK. The minimum thickness is 0.3 millimeters of the polyethylene foil, or we can have some adequate product of corresponding thickness. And again, it's contrary to the previous case. Here we have the minimum thickness, but if we change the radon diffusion coefficient, we will obtain different radon barrier properties. So again, this approach does not express the real barrier properties. The third approach is to make some correlation between the thickness and the radon diffusion length. This is used, for example, in Germany, where the requirement is that the thickness of the membrane must be at least 3 times the diffusion length of radon in the membrane. The problem is that even if I have membranes with the same D to L ratios, they can have different radon resistances, because the radon resistance depends also on the radon diffusion coefficient. So as you can see from the table below, even if I have the same DL, I can have significantly different radon resistance for different radon diffusion coefficients. So another approach is used, for example, in Slovakia or in Spain, and it used to be applied in the Czech Republic until 2019. It's a detailed calculation of the thickness of the membranes, of the membrane independence on the parameters of the building, such as floor area in contact with the soil, interior air volume, intensity of ventilation, then parameters of the soil, such as soil gas radon concentration and soil permeability, and lastly, the parameters of the membrane, such as the radon diffusion length in the membrane, and so on. The problem is that it's a complicated calculation. It requires the knowledge of many parameters. But on the other hand, it provides an optimization, or it enables an optimization of the design of the membrane. In Scandinavian countries, they usually follow the SINTEF guideline for approval of radon membranes. They prescribe the minimum radon resistance value by one value, and this is the 50 megasecond per meter. So this approach is in fact very easy to use. It's a simple approach, but it does not take into account other parameters such as the category of radon-prone area, or the type of the building, or the presence of other measures against radon, such as soil gas radon, subsoil ventilation, and so on. So, and the last approach is the approach that we use in our country, in the Czech Republic. It's in fact similar to the Scandinavian approach, but instead of one minimum radon resistance value, we have several minimum radon resistance value. As you can see here, they may vary from 2 megaseconds per meter to 300 megaseconds per meter. And the minimum values are chosen with respect to the type of the building, to the radon-prone category of the building site, and with respect to the presence of other measures against radon. So, in fact, this approach enables to optimize the design so that the possibility of over-dimensioning or under-dimensioning is minimized. So in this diagram, we can compare all these approaches. So here, this vertical line expresses the requirement expresses the approach that sets the minimum, maximum value of the radon diffusion coefficient. So only the materials which are below this line can be used. The green line expresses the requirement for the minimum thickness. So again, only the materials which are above the green line can be used. Then we have the approach from Germany. It's the red one, the red line. So only the membranes above the red line can be used. And this set of lines or curves, in fact, curves express either the detailed calculation according to the Spain and Slovakian approach, or the radon resistances, because in fact it's the similar approach. Radon resistance is applied in Scandinavian countries or in the Czech Republic. So yeah, it's a mesh, as you can see. So the result is that in different countries, one product can be considered as a barrier material, and in another country as a material that is not suitable or not applicable as a radon barrier material. So it's a complication for the producers and the suppliers of waterproofing products, because in fact they cannot state some requirements in their technical data sheets. So I think that the unification of the approaches would be beneficial. And in our workshop that we organized 1 month ago, when we have the representatives of several labs which measure the radon diffusion coefficient, we have agreed that the most efficient way how to express or how to prescribe some requirements for radon barrier membranes is to use the radon resistance, because as you can see here, the radon resistance of the product is a value that is prescribed by the producer in the technical data sheet, and the only we just compare this value with the minimum value, and the minimum value can be prescribed on the national basis. It can be tabelized, or we can have some detailed calculation of the minimum value. So it will depend on the national habits, for example, and so on. So here we have developed the equation from which each country can set or find some either one or several values of the radon resistance. according to the typical building characteristics, we can use some interior air volumes or ventilation intensities or floor areas. And each radon-prone category can be described by individual radon concentration, I mean concentration of radon in the soil gas. So this expression here can be used to find some minimum radon resistance value, which may differ according to the country. So here you can see an example of a table. It's from the Czech technical standard where the minimum radon resistances are prescribed. So as you can see that it's the set of values from 2 to here we have to 150, but this table is applied when the indoor radon concentration is 200 becquerels per cubic meter. If we want to have, for example, 100 becquerels per cubic meter in the indoor air, then all the values here must be or should be 2 times greater. So the values depend on the radon-prone areas, depends on the intensity of ventilation, and depends on the category of or types of buildings. So the question is, if we have such spread of minimum radon resistance values, whether on the building market there are some products which can cover this range of minimum radon resistance value. In this diagram, each dot that, oh, it's not a dot, it's a, okay, each dot represent one waterproofing product in which we have measured the radon diffusion coefficient. And here you can see its radon resistance. So you can see 650 dots. And for example, the minimum radon resistance to a megasecond is satisfied by, let's say, 98% of waterproofing products available on the building market. The SINTEF requirement, 50 megasecond, is satisfied by nearly 80% of waterproofing products. And the highest minimum radon resistance value, 300 megasecond, is satisfied by nearly 40% of products. So we can say that we have products which can cover the whole range of the minimum radon resistance value. And just for the comparison, here you can see the German requirement for that the thickness to the diffusion length ratio should be greater than 3, and this requirement is satisfied by only here some few products. Yeah, so it's a really strict requirement, and just the membranes with the aluminum foil or EVOC layer can satisfy this requirement. So the conclusion is that radon resistance seems to be the most suitable parameter for harmonization of the European approaches for the radon barrier materials. And we have agreed on a very simple and very short, just one-page standard with 3 paragraphs, which are written here, that the radon barrier must have a radon resistance greater than the minimum radon resistance value. The second paragraph, values of minimum radon resistance are prescribed by national building standards or national legislation. And the third paragraph, if there are no national values of minimum radon resistance, the values according to the table below are used. So we have simplified the Czech table, significantly simplified. So the resistance, the minimum radon resistance, is chosen independent on the category of radon risk of the foundation source or radon prone areas, because we have each country have its radon map. So the radon categories are known. Why not to use them? And then according to the whether the radon barrier is the only measure against radon, or whether the radon barrier is combined with another measure such as subslab ventilation and so on. So, and that's probably all. Yes, thank you for your attention.
You're perfectly in time. Thanks a lot, Martin. Are there any questions? Yes, please.
Thank you very much, Martin. That was very, very clear presentation comparing all the approaches. Can you go back to the slide 15, I guess? 15.
Yeah, 15. 15 is very high. Yeah? 15 is
yes, this one. Okay, so it's actually in conclusion the bullet 2. It's the only minimum number of products can be sufficient to meet the criterion of very strict criterion in Germany. The question: can you comment the products containing aluminum foil, since this is the perfect behavior and perfect property during the laboratory testing, but in field and on site it's something not really good, since the thin aluminum layer is not really
it has no elongation. Yeah, aluminum has no elongation. The problem is that the very low radon diffusion coefficient of such membrane is ensured by the integrity of the aluminum foil. But due to differential settlement of the building and so on, the aluminum is usually cracked or it loses the continuity. So the barrier properties are lost of such membranes in real conditions. So it works in laboratory conditions, but not in site conditions on the building side. EVOC is much better because it's a polymer, so it has a good elongation, but it's really expensive. So it's not a common membrane that is used in building industry.
There's one more question from Heloisa.
Okay, thank you. Martin, thank you so much for your presentation. I think this could be a way for the harmonization in Europe, yes. I only have one question about this. It's regarding the definition of the priority areas, because a lot of countries have different definitions. Some have 30% of the buildings above the action level, some have 10%, 5%, 1%. So how overcome this for this harmonization?
Yes, I know that the classification of the building sites into categories of radon risk may differ. Some countries use the indoor radon data, some geological data. For example, in our country, we measure directly the soil gas radon concentration on the building site and so on. But in fact, it's not so important which data you use, whether indoor data or soil data. The fact is that even the indoor radon data express the radon concentration in the soil. So it's the way how to fix this problem is to find the correlation between indoor radon data and the soil gas radon concentration. So you can, if you want to use the expression that I have shown for finding the minimum, this one, for finding the minimum radon resistance value and to find the CS. So I think it's just the discussion in your country, which concentration in the soil, because the geological maps are available for each country. So which concentration the soil corresponds to the indoor radon data. And then you can just simply insert your typical data in this equation and to find some minimum values. Yeah.
Thanks a lot. Is there a question from online, please? Yeah.
There is also one here.
First, Tanya.
Thank you. Thank you for the presentation. I have more practical question because I know that in some European countries, they have already in legislation that they have to implement these barriers or membranes in the new build, for instance, Ireland and Luxembourg and so on. And we also know that there is a lack of industry that they are doing this. So my question is, will this, your results, is there any potential that your results influence also the legislation, but also are you in contact with the industry so that they will implement these results into the building practices, especially in those countries where this is obliged, required by the legislation, but also in those countries where it's not really required by legislation, but the new build is still integrating these things. We hope that they will integrate the barriers. So legislation and your influence of your results on legislation and influence of your results on the building industry. Thank you.
Yeah, but the building industry is a wide term. So we have the producers. I think that the producers of waterproofing products are multinational companies. They operate not only in Europe, in the US, and so on. So I think that it's not the problem within the producers of the membranes. We get a lot of waterproofing materials of different chemical composition. Maybe that there may be some problems with the suppliers who install the membranes into particular building. But again, it probably depends on the building habits in each country, because in Central Europe, where we have clay soils, which are not so permeable, where we have high underground water table levels, it's quite common to use waterproof products. So the contractors are they know how to fix it and how to apply the waterproofing materials. Maybe in some countries where it is not common to protect the buildings against water and the soil moisture by continuous waterproofing, that the installers are not available. I don't know, but I think that it's not a special branch which cannot be learned. So it's I think that the industry is not maybe the willingness to apply the continuous barrier. That's probably the problem.
Thank you, Martin. There's one last question from an online participant. And then
one quick question from Thomas Beck online. Does the aging of the materials reduce the resistance?
Oh, sorry.
Does the aging of the materials reduce the resistance?
Yes, of course. Yes, but it depends on the material properties and material composition. So high-density polyethylene membranes are resistant to soil corrosion, for example, and their durability is many years. On the other hand, bitumen membranes or polyvinyl chloride materials, the duration is significantly smaller.
Okay, thanks a lot once more. Thanks a lot to all of you for attending this session. It's now time for coffee.